So today, this is on page 15. Oh, example 5. I'll come back to that later. Okay. So when on page 15, we're going to talk about tolerance. So tolerance is different than precision and uncertainty. Because when we talk about precision, remember this is an uncertainty. Both of these has something to do with the device for measurement. Right? So the measuring device, the ruler, how fine the ruler is, how many tick marks there are, and then uncertainty is something where uncertainty happens when the measurement falls in between the tick marks. So precision and uncertainty has something to do with the measuring device, measuring tool. But both precision and uncertainty have to do with the device used for measuring. The tolerance, however, is a man-made range of acceptable values. What's acceptable, right? Sometimes it's okay for a certain degree of values. So we can't have too little, but we also cannot have too much. That's what acceptable values are. It is used to determine if something will actually fit or be acceptable. Okay. For example, a nut is manufactured to thread into a bolt. Okay, so when all those screws, right? Those are fit, and there's acceptable measurement. If the nut is too small, it will not go into the bolt. If the nut is too big, it will be too loose and fall off the bolt. So the nut will have an acceptable tolerance or range that will allow the thread to properly fit. Right? So I'll give, those are the nuts and bolts, but I'll give you something that I quite use all the time. So you know that we have our calculator in here, right? So what happens when, so this is a measurement right here, this is a measurement right here, how wide these things are. What happens when this is gonna be, this lid is too big? What happens if it's too big? Right? I won't be able to securely put my calculator in here, right? It's gonna be too big, it's not gonna stay, right? My calculator will just fall off from here. Now what happens if it's too small? Now, if this thing is too small, then I'm gonna have a hard time putting my calculator inside the lid, or putting the lid in here on my calculator. So there's a degree of tolerance acceptable so that my calculator will fit in my the lid of it, or the cover. Okay? So there's an acceptable. It can't be too small, otherwise it won't fit, and it can't be too big because it would be too loose. So let's take a look at this one. A foot-long sub only needs to have at least somewhere around 12 inches, right? So we know that when we order a sub from Subway, or any sub, I guess, and when you ask for a foot long, you are expecting about a foot long, right? Is it going to be exactly 12 inches? Do you think if we measure all of the bread for the sandwich, do you think it's going to be all 12 inches? Exactly? Most likely not, right? Most likely not. Some would be slightly smaller, some would be a little bit over, but it's somewhere around 12 inches. Okay, so those are the tolerance. That's where you see tolerance in real life. Because tolerance refers to an acceptable range of values, the key word there is what's acceptable. There will be a minimum and a maximum allowable value. There's a minimum and there's a maximum allowed. So there is also a target value. So what we want it to be, like what we want our foot-long sub to be 12 inches, but it might be a little bit less, but a little bit more, but our main target is 12 inches. So a target value usually falls between minimum and maximum values. So the diagram below help us to kind of visualize the halfway point. So this is minimum, this is the maximum. Minimum, the smallest value that's allowed, the biggest value that's allowed. The target would be somewhere in the middle, right? The target is in the middle. So the full tolerance is how much is the distance from minimum to maximum, right? So the full tolerance is the distance or how much it is from minimum to maximum. This is half the tolerance, halfway, and another half. So it's usually a good idea to kind of visualize this like this. Let's take a look at example number 1. So a ride at Red River Exhibition has a desired ride time of 5 minutes. So that this is what they want, 5 minutes, right? That's a target. That's a target. If the lineups are long, the carnival worker can shorten the ride by 2 minutes. Okay, so the worker can shorten the ride by 2 minutes. If it's a slow day, they can add up to 2 minutes, up to 2 more minutes. So let's complete the diagram and we'll figure out the minimum, maximum, and so on. So this is the desired ride time. So that's our target, 5 minutes. Now, if the line is, if it's busy, then what they're gonna do is they're gonna shorten the ride by 2 minutes. So what are they gonna do? Shorten the ride by 2 minutes. So that would be minus 2. So that's gonna give us 3 minutes now. And then if the line, if it's a slow day, they could add up to 2 minutes. So that's going to be 7 minutes. Okay. So what's acceptable in this situation? It's acceptable for a ride to be at 3 minutes up to 7 minutes. So from 3 minutes to 7 minutes, those are the acceptable ride time. Okay. So from here, how much is the tolerance here? How big is the tolerance? So from 3 minutes to 7 minutes, that's going to be 4 minutes. 4 minute tolerance. You can adjust up to 4 minutes. So how would you get that? It's easy when it's like this, right? You can just say, hey, the difference between these two is 4. You can go 7 minus 3, maximum minus minimum. Oh, I want to put minutes here because that looks like minimum. Okay, so 7 is our maximum time, 3 is our minimum time, so the difference is 7 minutes. So this is the full tolerance. So what is the half tolerance? Half tolerance would be half of 4 would be 2 and another 2. Okay. So how can we get from 5 to 3? Well, we subtract by 2. How can we go from 5 to 7? We added 2, but the tolerance is 4, half is 2. Is that okay? Yeah, you can. Look at the next one. Ooh. Example number 2. A person's blood sugar level should be between 80 and 120. Okay, what are they giving us? 80 to 120. So they're not giving us the target, but then they're giving us the range of what is normal, right? So minimum, maximum. These are the acceptable values. Acceptable values would be 80 to 120. Okay, so where would that go in our level chart here? So where would the 80 go? Here. So 80 goes here. 80 milligram per deciliter. Okay, and then the maximum would be over here, 120 milligram per deciliter. Okay, so we have a minimum, we have a max. I'll just put minimum, maximum. What do you think is the target value in the middle? What do you think the target value in the middle? Is there any idea on how we could figure that out? Yeah, you can say it. In the middle would be? Of those two numbers? Yeah. Oh, okay. Yeah, middle. Okay. Here's what we could do. Okay, here's what we could do. What is the full tolerance? So let's figure out the full tolerance first. Full tolerance. Full tolerance is how far is it from 80 to 120? How far is it from 80 to 120? That would be 120 minus 80 equals to 40, right? 40. So that's a full tolerance, full spread from minimum to maximum, 40. Then what would be half of the tolerance? If this is 40, then this one would be half would be 20 and 20. Okay. So what do you think the middle is? A 100? Yeah. Yeah, 100. So 100 would be in the middle between 80 and 120. Because from here, from minimum to the middle, you can add 20 to this side to make it 100. Or from middle to go to the minimum, you subtract 20. Okay, let me repeat that. Minimum to the target, you add the 20. From the target to go to the minimum, you subtract 20. So 100 milligram per deciliter. Okay. Another way of doing that is figuring out the average of the two. I know we haven't talked about average yet, but we will later on, but might as well talk about it. So the average is the middle value. That would be 80 plus 120 divided by 2. So that's going to be 200 divided by 2, which is 100. So we could figure this out also using the average method, figuring out the average. Okay, so what does that mean? Our minimum is 80, our maximum is 120. The full tolerance is 40. That's how much wiggle room we have. We have 40 milligram per deciliter. So split that into 2. So half, 20 here, and another 20 there. Is that okay? Take a look at the example number 3. The target value of the weight load of a bungee cord is 200 pounds. Okay, so the target, so that's what they wanted to do, to have a bungee cord weight load 200 pounds. Okay, with a tolerance of 20 pounds. Circle the following weights. Circle which of the following weights of items this bungee cord could hold. So what can we do? Well, we don't know. We know the target is 200. So let's draw it out. Minimum, maximum. We know the target is 200, so that's going to be 200 in the middle. Pounds. And then they said here the full tolerance, the tolerance is 20 pounds. So that means the spread from minimum to maximum is 20 pounds. So full tolerance is 20 pounds. Okay. So if the full spread from minimum to maximum is 20 pounds, what would be the half? Half would be 10 and 10 pounds. So what can we have for minimum? 200 here. What do you think the minimum is? It's going to be 200 minus 10, which 200 minus 10 is going to be 190 pounds. And then to go to the maximum, 200 pounds plus the 10, 210 pounds. So that tells us the cord can handle 190 to 210 pounds. Of weight. Okay. So we can't do that right now here, so we have to kind of organize it so that we can figure out what's acceptable. Okay. So we know it's 200, full tolerance is 20. So that gives us 10 and 10. So subtract 10 to get 190. Add 10 to 200 to get a 210, and then from here we can find out, oh, I can go 190 to 210. Now, from all of these, which ones would fit in that situation? Which ones are acceptable? Is 195 acceptable? 195 would be within the range of acceptable values, so that's okay. Is 215 okay? No, it's too much, right? Okay, so no. Is 180 okay? It's too little, right? Is 202 okay? Yeah, 202 is within this acceptable values. And 197, yeah, that's okay, because that's within the acceptable values. Okay, how do you feel about that one? Is that okay? Just figuring out what's acceptable and what's not. Okay, number 4, example number 4, the last one. It's a short one. Sylvester works at a machining shop. He is working with a machine part that has a tolerance of 0.02, a very small tolerance. Very, very small, 0.02 millimeters. If you think millimeters are really, really small, 0.02 is even smaller. Yeah, that's a very small tolerance. The desired length, okay, so the desired length is 70 or 0.70 millimeters. State the maximum and the minimum value of the machine part. What's acceptable? What's the maximum acceptable value? What's the minimum acceptable value? So let's see if we can draw it out. This is really good for representation, right? We know this is minimum to the left, maximum to the right, target in the middle. Okay. And then this is full tolerance. So what do we have so far? We have a tolerance of 0.02. So that means this is 0.02. And we know that the desired length is 0.70. Yep. What's that? 70? I missed it. Are you sure? Okay. 0.70 millimeters. So they're all millimeters. Okay, so now how can we figure out the minimum and maximum? So we know if the full tolerance is 0.02, the halfway would be 0.01, 0.01. So minimum would be, what would this be? 0.70. If you go this way, you're going to subtract 0.01, so it's going to be 0.69 millimeters. And then if you go this way, it's going to be 0.71 millimeters. So it's a very, very, very fine range of values, right? So maximum is 0.71 millimeters, and then minimum is 0.69 millimeters. Okay, and those are the acceptable. If it's not within those acceptable values, it's probably tossed out, right? Because it doesn't work. It's either going to be too small or too big for whatever purpose it is for. Okay, so that's great. That's a really short one. Certainly, there's some assignment questions for you to try on your own, okay? Or if you have somebody to try it with.